Hello and welcome to this lesson. In this lesson, we will learn about the physical layer. First, we need to understand what is LAN. LAN stands for Local Area Network. LAN refers to a collection of devices connected together in one physical location. There is a small size, medium size, and big size of LAN. Let's see our example here in order to understand what we mean by LAN. So our company has a branch in New Jersey. Inside this branch, we have one router, 6 switches, and multiple users. We can refer to our network as a LAN network because all of those equipment located at New Jersey branch. Inside our network, we have Bob and Jack. They are employees at this company. So when Bob wants to send the traffic or send the data to Jack, he will use the LAN. The reason of that, because Bob will use the internal equipment or the equipment that exists in our location, and the data will not go outside our network. So there is something also called WAN. So we have our LAN, as we spoke before. So what is WAN? WAN stands for Wide Area Network, and as you can see in our example, we have another branch in Tokyo and Chris works in that branch. So when Jack wants to send the data to Chris, he will use the WAN in that case. So as a network engineers work at our company, let's say it's company X, we know what type of equipment we have in our LAN. We know what type of switch, what type of router. We can change the traffic path. So we can do whatever we would like to do in New Jersey or Tokyo branch. But when we want connection between our branches, we're not gonna run a cable from a country to a country or a state to a state. In that case, we can request company called ISP or SP, Internet Service Provider or Service Provider. Here in United States, we have a Verizon, we have Xfinity. Those companies doesn't only provide internet access for user, it provide a connection between companies and branches. So in our case, we're gonna request one of the ISP company to connect our branches together. So we will not know how is the traffic will be forwarded in the middle here in the WAN network, and our connection will be considered as a point to point, but we cannot manage the traffic in the WAN side. We cannot change any configuration in the equipment. We cannot, or we do not know what type of equipment used here. For CCNA, we will learn about two types of LAN. The first type is something called SOHO LAN. SOHO stands for Small Office Home Office LAN. And when we describe SOHO, we are talking about a very small network. Could be one router, one switch, one router, two switches, and multiple users. For CCNA, we will focus at the enterprise LAN. So enterprise is a medium-sized network, and it's a type of organization-size network. Inside this network, we will find multiple floors, multiple switches are in those floors, multiple users. So how is the network will look like? The enterprise network consists of 3 layers. So some people also using those terms in order to call the switches. So they are referring to that switch as a core switch, those switches as a distribution switches, and this switches as a access switches. So our access switches will be connected directly to the end users. The distribution switches will be in the middle between the core and the access. And our core switch will be connected to a router, and this router could be connected to the WAN. So the core switch should be very powerful switch because it receives requests from access distribution switches and forward those requests to the router. So as you can tell from our example, the users will send the traffic to the access switch. The access switch will send the traffic to the distribution. The distribution will send the traffic to the core. and the core can forward the traffic to the WAN connection. This in case of we are using the WAN, but if we are using our LAN, for example, if Bob sending traffic to Jack, access switch will take the connection or take the request from the end users, send it to the distribution switch, and the distribution switch will forward the traffic back to one of the access switches. The big reason behind this type of enterprise network is that we don't want in our network to have a single point of failure. So the physical components that we have our cables in our network. We have the copper Ethernet, the fiber Ethernet. We have a cable called DAC or direct attached cable. We have also something called SFP or a small form factor pluggable TRAN receiver. And we have the NIC card or network interface card. If you are using right now a desktop and you are connecting your desktop with a cable, the cable will be plugged on the NIC card. Also, if you are using a wireless laptop, in that case you are using a wireless NIC card. For switches, we don't use the term NIC in order to describe the network interface card. For the switch, we call it blade. So as you can see, the blade consists of multiple ports. So before we start with the cables, what is the SFP TRAN receiver and why do we need it in our network? So let's imagine we have one of the distribution switches or core switches, and this switch connecting router and the multiple switches together. So what will happen here in our design if one of the ports goes down? It's damaged or something happened to the port. In that case, we have to replace our switch. And in order to replace our switch, we have to disconnect the power, disconnect our router, and disconnect our switches. Take our switch and bring a new switch, configure our switch, right? This is not appropriate in the production because in that case, there will be an outage time and all the companies trying to avoid that. That's why we have the SFP. So the SFP will be a removable connector. So if you can see right here, those two ports are empty. It doesn't have an Ethernet or fiber connector inside it. For those ports, we are using the SFP and we plug it here. And if there is a damage or if the SFP is damaged, we don't have to shut down the switch and we don't have to replace our switch. In that case, we can remove the SFP and replace it with another new SFP. So if we are using SFP between two switches, we will need two SFP and one cable, right? So one SFP will plugged in the first end and another SFP will plugged in the other end, and then we need a cable to connect those ports together. So we have another choice here to use the DAC cable. The DAC cable have SFP on both ends, so there is a SFP right here. There is SFP here and SFP on the other side. So we can use the SFP or we can use the DAC cable. So the SFP comes in a copper SFP and it comes also fiber. So we have a 1 gigabit SFP. We have a SFP plus, which is 10 gigabit per second SFP. And we have also quad SFP. For quad there is 40 gig SFP. We mentioned that there is a copper Ethernet cables and the fiber Ethernet cables. So we will start with the copper Ethernet cable. The copper Ethernet cable consists of 4 pairs of copper cables. As you can see in our image right here, there is a 4 pairs inside the cable itself. The copper Ethernet is a standard and the standard name for this cable is 802.3. The Ethernet cables can come with UTP or unshielded twisted pair and STP or shielded twisted pair. Shielded twisted pair is expensive than the unshielded twisted pair. So the shielded twisted pairs is covered by a shield, and the reason of using the shielded twisted pair, in case of our Ethernet cable will run nearby any power cable. So the STP cable will reduce the electromagnetic interference. But most of the time we will use the UTP, the unshielded twisted pair, because the unshielded twisted pair is cheaper than the shielded twisted pair. So how can we measure the speed of the cable? For the cable's speed, we're using some units of measurement for bits. So we have the kilobits, megabits, and gigabits. We will use those symbols to refer to the kilobits, megabits, and gigabits. So the kilobits is 1024 bits, the megabits is 1024 kilobits, and the gigabits is 1024 megabits. For the copper Ethernet cable, we have multiple types of the cables. There is actually more than those, but for CCNA, we need to learn about those only. So we have the Ethernet, the fast Ethernet, the gigabit Ethernet, and the 10 gigabit Ethernet. So the Ethernet is 10 megabit per second. The standard name is 10 base T. The formal name is 802.3. And as you can see, all the standard or the formal IEEE name start with 802.3. This cable is copper and can run up to 100 meter. There is the fast Ethernet, which is 100 megabit per second. Standard name is 100 base T. The formal name is 802.3U. This is a copper cable, can run up to 100 meter. There is also the gigabit Ethernet cable. It's 1000 megabit per second, 1000 base T, 802.3 AB. It's a copper cable and can run up to 100 meter. There is also the 10 gigabit per second Ethernet. This cable speed is 10 gigabit per second. Standard name is 10G base T. The formal name is 802.3 AN. And this cable is a copper cable, can run up to 100 meter. So let's ask a question here. Is the speed depend only on the cable? So let's take a look at our example here in order to understand how is the speed will work between two devices. Here I have an interface. This interface is Ethernet interface. And I have here a fast Ethernet interface. Those two switches is connected with 100 base T cable. So what is the link speed in that case? So the link speed or the speed between the two switches will be based on the slowest interface, which is Ethernet interface. So it will be 10 megabit per second. And the reason of that, because this interface will not be able to transmit or receive the data faster than 10 megabit per second. However, as you can see, our cable is 100 base and this interface is a fast Ethernet. However, this interface cannot transmit and receive data faster than 10 megabit per second. So there is a protocol work behind the scenes. This protocol called auto negotiation. So if we take a look at our switch here, so this is a show interface status command in this switch right here. And as you can see, the interface fast Ethernet 10, which is this interface, it's saying right here, it can support 10 or 100 base TX. So if the other side, which is this side, is fast Ethernet, the connection speed will be fast Ethernet. If this interface is a Ethernet, in that case, this interface, the fast Ethernet interface, will reduce the speed and it will become Ethernet interface because the other side cannot support faster than this. We need to take a look at the 1000 base T UTP cable. So this cable have a speed of gigabit Ethernet, and if we are using that type of cable for the connection between the switches, This cable will use the 8 cables for transmitting and receiving the data simultaneously. If we are using the 10 base T and 100 base T UTP cable, in that case we will use only 2 pairs to transmit and receive the data. The 10 base and 100 base can be connected with a straight through connection or crossover connection. So what is the straight through and the crossover? So let's start with the straight through. As you can notice right here, there is 8 pins inside the RJ45 connector. Each one of the 8 cables will go inside these pins. So when we use the straight through connection, we connect the first cable at the first end to the first pin at the other end. 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, 8 to 8. So if we are using those colors in order in one side, we have to use the same colors in order also in the other side. So why do we use it that way? We can use the straight through connection or straight through cable between desktop and the switch. The reason of that, because the desktop transmit data on pin 1 and 2, receive data on 3 and 6. The switch is receiving data on 1 and 2, transmitting data on 3 and 6. So if we use the straight through between desktop and the switch, as you can see, one end transmitting data, the other end is receiving data. One end receiving data, the other end transmitting data. So the straight through cable will work properly between desktop and the switch. So what about a connection between a switch and the switch? If we used the straight through cable, in that case it will not work. The reason of that, because the switch in both ends receiving in pin 1 and 2 and the transmitting in both ends in 3 and 6. To connect the switch and the switch together, we are using something called the crossover. In crossover, we are connecting pin 1 to pin 3, pin 2 to pin 6, pin 3 to pin 1, pin 6 to pin 2. Then the rest of the cables will go in the same order in both ends, 8 to 8, 7 to 7, 5 to 5. So let's see the crossover, what will happen when we connect the crossover between switch and switch. As you can see in our example, we connected 3 to 1, 6 to 2. So as you can see in the example, this switch is transmitting data on 3 and 6. This switch receiving data on 1 and 2. Let's continue with that connection. We will connect 3 and 6 here to 1 and 2 in this side. As you can see in our example, this switch is transmitting data on 3 and 6, and this switch is receiving data on 1 and 2. So as you can see, the crossover will work properly here in our example, and the rest of the cables will be connected as a straight through. So 4 to 4, 5 to 5, 7 to 7, 8 to 8. So you can ask a question right now. What type of cable should I use for my connection? Should I use a straight through or crossover cable? So let's take a look at our table right here in order to know how is the devices transmitting data, which pins they are using. So we have the first category here, the devices that transmitting data on pins 1 and 2, receiving data on pins 3 and 6. We have a desktop, we have router, access point, and the firewall. The second category is the devices transmitting data on pins 3 and 6 and receiving data on pins 1 and 2. We have switch and the hub. If we are connecting devices from the same category, we're gonna use a crossover. If we are connecting a switch to a hub, we have to use a crossover. Same thing if we are using a connection between desktop router, we should use a crossover. But if we are connecting devices from the different categories, for example desktop to a switch, in that case we can use the straight through cable. So by default the switch is receiving data at pins 1 and 2 and transmitting data on pins 3 and 6. This is the default configuration for the switch. But we actually have another feature on the switch which called Auto-MDIX. So when Auto-MDIX is enabled on the interface and it's enabled by default, the interface will automatically detect the required cable connection type. Then it will configure the connection appropriately. The command to enable the Auto-MDIX, it's MDIX Auto. So you can go under the interface configuration and type this command MDIX Auto, which is already configured by default. Let's see our example here to understand what is Auto-MDIX and how it works. Here is the default configuration for the interface, receiving in pins 1 and 2, transmitting on pins 3 and 6. The other end is that connected to our switch, transmitting data on pins 3 and 6. In that case, when our switch has the Auto-MDIX configured on the interface and it detects data coming at pins 3 and 6, it will change the pins, so the pin 1 and 2 will transmit data and pins 3 and 6 will receive data. So let's discuss the fiber Ethernet cable. The fiber Ethernet cable use glass and bend it hard could damage the cable. So we have to be very careful when we are using fiber cable. And as you can see here, the core is responsible for transmitting the data. And as you can see, it's shielded with multiple layers. So there is outer jack, there is a strengther, buffer, cabling, all of that to protect the core. So the Ethernet copper cable transmitting and receiving electronic signal. The fiber cable is transmit data through light. So the fiber will use light to transfer the data. Fiber cable is faster than the copper cable, and the fiber cable also support long distance. It supports longer distance than the copper cable. For the fiber cable, we are using two cables only. One cable to transmit data and one cable to receive data. The fiber cables have two types or two modes, single mode and multi-mode. The multi-mode support longer distance than the copper cable, but compared to single mode, it supports shorter distance. The cable itself or the core itself reflect light. So as you can see in our example, the core itself reflects light. So the light doesn't go in a straight line. The multi-mode fiber cable is inexpensive compared to the single mode. Then we have the single mode fiber. It supports longer distance than the multi-mode. The light in case of single mode goes in a straight line. As we can see in our example here, unlike the multi-mode, this type of cable is expensive. Those are some standard for the fiber cable. We have the 10G base S. This cable is multi-mode. It can support 400 meter. We have also the 10G base LX4. This is a multi-mode, can support 300 meter. We have also the 10G base LR. This is a single mode, can run up to 10 kilometer. We have also the 10G base E. This is a single mode, can run up to 30 kilometer. So how is the companies using the single mode fiber, multi-mode fiber, Ethernet cable? Let's take a look at our switches here in order to understand what should be connected with the Ethernet copper cable and what should be connected with the fiber cable. So most of the end devices are connected with the Ethernet copper cable. This because if you saw your desktop, you will find the Ethernet port, you will not see fiber port. Same thing with printer, for example, and access point. Also, the copper cable supports something called PoE, or power over Ethernet. So instead of running two cables to access point, for example, one cable for the power and another cable for the connection, we can use the Ethernet, and the Ethernet support PoE. It can provide power to the access point through the Ethernet cable. So some of the switches support PoE. It can send the power with the data through the Ethernet cable. So most of the end devices are connected through copper cables because the endpoints are supporting the Ethernet cables. But when we connect the switches together, so those switches could exist in a different rooms, different floors. So we can have one switch in the first floor, another switch in the third or fourth floor. Plus also the connection between switches will need a very high speed cable. So for example, this computer right here can send data to that computer. In that case, the data will go through that link. And not only those two computers, it could be all the devices are sending data and using that cable to send the data from one switch to this switch. For that reason, we are using the fiber cable between switches. This is the end for this video. Thank you for watching and see you in the next one.